Now we want to graph f of x equals -3. Now remember, this is, the negative comes after we raise it to the power. So if we used x was -3, it would be 1, we would flip it 1/3, cubed would be 1 over 27, and -1 over 27. Working on my x and y values. -2, 3 to the -2 would be 1/9, and we want negative of that, -1/9. -1, 3 to the -1 would be 1/3, and negative of that, 1/3. 0, 3 to the 0 would be 1, negative of that, -1. 1. 3 to the first is 3, negative of that. And 2. 3 squared is 9, negative of that, -9. Well, -3, -1/27 is barely going to be there. -2, 1/9, -1, 1/3, 0, -1, 1, -3, 5, 7, and 2, -9. How did we end up with an exponential function below the x-axis? It looks like the x-axis is still an asymptote. But why did that happen? Because of the negative. Remember, multiplying a negative flips it, a function across the x-axis, flips it down. So my domain is still from -infinity to infinity, and my range now is from -infinity to 0 with a parentheses. What should this -2 do? It should move this function to the right. Remember, it's with the x, so it should move it 2 to the right. Now let's take a look and think. Our basic functions, we know if we have 3 to the x, we would have -1 and 1 over 3. If we would have 0 and 1, and we would have 1 and 3. But we're going to move these 2 to the right. So -1, 1/3 would be right here, but we're going to move 1, 2 to the right. 0, 1 would be here, but we're going to move it 2 to the right. 1, 3 would be here, but we're going to move it 1, 1, 3 would be here, and moving it 2 to the right would make it here. So notice we still have that very same similar shape. It's just moved 2 over. And if we think about that, that does make it much faster to graph than at doing the actual points. The domain is from -infinity to infinity. The range is from 0 to infinity. And I did do these 1, 2, 3 points I used for my graph. Now, remember what this -2 tacked on after the function does. It moves it down. So again, we would have 3 to the x, we would have -1 and 1/3. We would have 0 and 1, and we would have 1 and 3, but we're going to move these all 2 down. So negative 1, 1/3 would be here, but move it 1, 2 down. 0, 1 would be here, but move it 2 down. And 1, 3 would be here, but move it 1, 2 down. What actually happens is this moving it 2 down moves the asymptote. Instead of it being at the x-axis, it becomes at the y = -2 line. That moved my asymptote down. So I'm going to draw in the asymptote, and now I can draw in my graph. And I have used 1, 2, 3 points for my graph. The domain and range, the domain is still -infinity to infinity, but the range has moved. Now it's moved down to -2, still to infinity. Next, we want to learn about the number e. The number e. A calculator gives the results for various values of n. And what we're evaluating is the function 1 plus 1 over n raised to the nth power. Now when n is 1, that's 2. When it's 2, it's 2.25. When it's 5, it's 2.48832. When it's 10, it's 2.59374. We have 100, 1,000. 10,000 is 2.71815. A million is 2.71828. It gets closer and closer to some fixed value. Notice that we've got 718. And this really is the case. And the fixed number is called e. So in mathematics, e is a real number and not a variable. It is a real number, not a variable. Now, value of e to 9 decimal places is 2.718281828. It appears to start repeating here, but it really does not start repeating. That's only what it's approximately equal to. It is an important number in math, and as we get later into this chapter, we will find that we will be using e as a certain value.